Today we're going to be looking at a time series forecasting example in Wallaroo. Specifically, we're going to see how we can go ahead and deploy an LSTM that is meant to forecast my time series, how I can set up external data connectors to feed production data into that model, and how I can ultimately set up automation around this so that I can call this whole workflow on demand or schedule it to recur at a regular basis. What we're looking at here is the Wallaroo Operations Center dashboard. And so this is going to allow us to manage our models, our pipelines, and control how we deploy and undeploy resources and invite collaborators to work on those projects with us. Before we dive further in, let's take a moment to talk through the various components of Wallaroo and how they relate to one another. First, I want to talk about workspaces. So workspaces are a place to organize your work within Wallaroo. Some organizations choose to have a workspace per project or initiative. Some choose to have one for every team. That's really up to you. Within a workspace, we have the ability to upload models, and these are exactly what you think of when you think of models. They could be an LSTM using TensorFlow, which is actually the example we're going to run through today. They could be any of the various sklearn models, etc. I can take these models and chain them together into pipelines. So a pipeline can consist of one or more models, and these can be various steps that we chain together, and ultimately these are going to be the unit that we actually deploy, feed our input to, and receive output from. Finally, I can assign users to a workspace, and this is going to control both security and the permissions of who can and can't do things like upload models, edit pipelines, etc. All of these components can be observed and administered inside of the Wallaroo Operations Center dashboard. So as I can see here, I can see what collaborators I have present in my workspace. I can see what workspace is currently selected, and I can see things like the models and pipelines here in my workspace as well. Clicking into them, I can see details like the one model that I have in my current workspace. I can see how many versions it has. I can see any pipelines that utilize it. And clicking into those, I can see other information around the pipeline itself. I can see that it's currently deployed, control whether I want to undeploy it, and see things like the version history and engine configuration. I can also monitor things like performance metrics, load metrics, and things like drift detection from here as well. Now I can go ahead and click this Launch Jupyter Hub button to launch our local instance of Jupyter Notebooks, where I can perform some of these operations programmatically. From within our Jupyter Hub, we're going to be working with the popular airline passenger forecasting dataset. And as I said at the beginning, we're going to run through how we can actually deploy a model to production using Wallaroo, in particular our saved TensorFlow LSTM model. We're going to walk through how I can make connections to external data stores to fetch information from there, and then how I can automate these forecasting jobs to be run on demand or at scheduled intervals. And so running these first few pieces of code, I'm going to show what we aim to produce as the final outcome here. And so this is a function that ultimately is actually taking some historical data from a data store, taking our deployed LSTM, and running that forecast to forecast what the next time point will be. So I can see here my plotted historical data that is retrieved up to what we're simulating as the current date, and then forecasting the next time point. And then what we're going to do is simulate at the next time point, when I want to take the next batch of data and forecast one step further, how I can roll forward and do that. And so you can imagine a scenario where we're forecasting these outputs once a week, relying on this model to give us this piece of information. And what we're essentially doing here is simulating, stepping through, grabbing that production data, running inference on my production deployed model or models, and then sending that information back to be consumed by the user. The first step to getting this kind of automated batch processing set up is uploading and deploying our model to production. We can do that in just a few lines of code by using Wallaroo to first connect to the instance, define the workspace that we want to set this up in, uploading our saved TensorFlow model, configuring the pipeline to have the kind of hardware that it needs to support it, and ultimately deploying that pipeline. Now that I have this pipeline configured and in production, it's ready to receive input data and start to return inferences, which in our case is this forecast. I can go ahead and load in a little bit of sample data, which we can see here is a 3 time point array representing the last 3 time points in our historical data that have been scaled. We can then convert these into a format that the Wallaroo inference function expects. And so we reshape that into a data frame where we have each inference as one entry. And so for this example, we're just going to start off with one inference, and we can see that here. And then I can run the infer function in order to see the output of this. And I can see based on these results that we have our inputs as we saw above, and we have our, again, scaled output format. Once I've confirmed that my model works the way that I expect by running it through some of these local tests like we just did, the next step is getting this connected to what kind of data I'm actually going to use for production. So in this kind of automated batch processing workflow we're talking about, probably I need to reference some sort of data store that's updated regularly so that every week or every day when I run these batches, I'm always getting the freshest data to feed to my model and getting that most up-to-date forecast. Wallaroo supports this through a feature called connections. Now, you would be able to work with your IT partner in order to get things like the proper credentials to actually start this connection. Once that's registered in Wallaroo, you'll be able to get it by using this wallaroo.getConnection function along with the name of your data store. In this case, we're dealing with a BigQuery data set. And so we're going to get that connection, use that to create a BigQuery client that we can interact with live, and ultimately send queries to that BigQuery data set and get those results back. And so I can use these results to query my live updating data and make sure that I'm getting that up-to-date information for my forecast. Now that I have a model in production, receiving data, making inferences, and a connection to my live production data store that contains the data that'll be refreshed and which I can base my forecast off of, all that remains is to actually add automation around these things. And this can be done using a feature in Wallaroo called ML workload orchestrations. Now, let's take a moment to talk about what an orchestration actually is, and then we'll walk through how to create one. So the idea with an orchestration is that at its core, it is a Python file, one or more Python files to be exact. And these can really contain anything, any kind of processing code, any kind of other dependencies that we need. But the idea is that these will contain references to one or more Wallaroo deployed pipelines so that I can schedule runs of these files and they can reference these pipelines that are deployed as needed. It also fully supports those connections that we made. So I can have as many of those connections as I need. And we often see people using these automations to take live input, feed into these pipelines, and then write the results to potentially another external data source or file store. Once these are set up, I can wrap them all in this orchestration and actually register that orchestration within Wallaroo. And what that means is that I can then create what are called tasks or runs of this orchestration. These can be done both on demand, so I can on demand submit a series of inputs and have this orchestration run, or I can schedule this to recur on a regular basis, meaning that this orchestration will run every minute, day, week, month, whatever I need. Now let's jump back into the code and see how I can actually create one of these orchestrations. So as we talked about, the center of this is this Python file that we have as main.py here. And so if I go ahead and open this up, you can see here we have a lot of the same steps that we've walked through together in this notebook. And that's kind of the intent here, is that I would prototype in a notebook, and when I'm ready to finalize and automate this, I move it into a file like this so that I can run it repeatably. Once I have that file defined, I can create a zip file from that file and any other dependencies that that file might have, give it a name, and call the upload orchestration function to actually register that with Wallaroo. Now, once it's registered, I should see it in this orchestration list as I do here, and I can see it has the name that I assigned it and the zip file that I've referenced. And once I have that, it is ready to have tasks run on it. And that is essentially instances or jobs that are based off of this code. And so I can do this via the orchestration.runOnce function, where I can give the task a name and feed it any input arguments that I have, and that will kick off a run of my orchestration. Now that I've kicked off this task to run, I can manually check its status, and I can see here that it completed successfully. And I also have the option to block based on it completing. Similarly, I can use the run scheduled function to set up regularly scheduled runs of this orchestration as well. You can see it takes a cron schedule, and so what I have here is a cron schedule representing a run at 11 p.m. every Sunday. And so essentially the scenario that we're playing out here is I want to run some kind of forecast every week. So every Sunday night, I will have this set to take some set of inputs and run the orchestration that I've defined here. And now I have everything in place to really run through a forecast of the kind I saw in the beginning. So essentially what this is doing under the hood is it is kicking off an on-demand run of this orchestration that I've scheduled. Says grab all of the data up to the current date. Once it does that, it runs my LSTM model to get that next forecast step, and then returns that result here to be plotted. And so essentially what I'm doing here is simulating a run like the one we scheduled to run once a week above to say step through this time, right? So every week I go back, there is new data that's available for me to run a forecast job on. I get that forecast, and then I can observe those results and make any decisions that I need accordingly. And so I have a fully automated process that I can run on demand or on a schedule. Once I'm done with that, I can free up the resources for my pipeline by calling the undeploy function. This will clean up everything and allow other people to use the resources that were claimed by this pipeline. And that's everything I need to do to set up automatable tasks that leverage production models in Walrus.